So let me introduce our next speaker, Chris Erdmann. Chris is an author, developer, and experimenter in the area of digital libraries, social networking, library UX, interactive technologies, bibliometrics, and data services in libraries. He's previously worked for organizations such as the European Southern Observatory, the Supreme Court of the US, United Nations, University of Washington, the Smithsonian, NMAH, and CNET. Chris holds an MLIS from the University of Washington iSchool and a BA from the University of California, Davis. Thank you.
Hi. Thanks for inviting me here. This is it's an honor. I want to talk to you about something that I think is near and dear to my community, but I think it's growing also very much of interest to other communities. And the talk, I'm going to talk about research software, but the Rewarding the Tool Builders title comes from actually a talk that I heard from Ed Lazowska from University of Washington at an OSTP event, and he highlighted actually the just the importance of research software in the scientific endeavor. That there's actually a lot of waste in the system, that we should be making it easier for people to find software that they can use, to reuse it, but also he emphasized rewarding the tool builders because this was critical to the infrastructure of science. So when I heard that talk, I immediately thought of someone who's very prominent in our community. His name is Tom Robitaille. He's an astronomer. He studies galaxy formation, but I guess on the side, he also develops software that is very critical to our community, library packages that people use. It's called AstroPy. And so actually on the side, I have two different versions here of a paper that they wrote about the software, and then the GitHub repository for AstroPy. And just to give you an idea, so if you don't know what GitHub is, it's a place where programmers share their code, they publish their code, but it's just really a much powerful tool for revisions, for versioning your software, and just collaborating with other software developers. And so this just highlights the difference between the developers trying to represent their code in different ways. And this is another screenshot of actually the number of citations that Tom has received for that paper, and then the number of downloads just in a month of the same software package. So you can see it's being used heavily, right? But then you see in the citations that it's not really representing that use to a certain extent. So this has been sort of a growing problem. Like I guess before GitHub existed, people would just link to their websites. But GitHub has become more of a powerful tool in our community. It's actually ranked 89th among websites as far as popular websites in the world. So it's really heavily used. And so you can see it now. The authors are trying to sort of insert their GitHub links in various places within papers, right? And just to give you an example too, that there's a link down at the bottom if you have time it's at the Astronomer source code library of different software citation styles. But I just wanted to emphasize that GitHub, they have this place on GitHub called the Danger Zone. I want the Danger Zone song, from the Top Gun to be playing in the background here. But they really emphasize the fact that they're not a preservation tool. So this screen really represents that. So I work with a group of, actually with Arfon, Smith, and some other people at CERN who were really interested in this. Arfon comes from the Zooniverse Citizen Science group, and he created a guide. So he worked with the CERN folks, and he created a guide to depositing your software very easily for the software developers, right? So I don't know if you can see, there's a lot going on here, but the basic thing is that you can link up your your GitHub account with Zenodo, which is actually running on the CERN infrastructure. So it's running on another software called Biennial. And you can link it up with your repository. And once you make a release of your software, you get a DOI. You get a DOI badge down there that you can put on your GitHub repository. And then Zenodo also pushes your JSON file, so all your metadata, corresponding metadata, back to the GitHub repo, right? And I think there's, let's see if I missed anything. No, I think that's about it as far as describing the process. So once you can see this steep increase, that's like the Arfon effect. Once he actually sent out that guide, that 10-minute guide for developers to use, it started exploding, I think, in my opinion. I mean, their research software is sort of more of a limited area, but it started exploding. And so now it's close to 3,000 deposits that they've had for people actually getting DOIs for their software. And it's continually being used. So this was a comment. Actually, this is I heard Authoria being mentioned earlier by Dan. This is a little project we call the Paper of the Future, using Authoria to sort of demonstrate some of the things we want to do, things that we want to experiment with. And it was a project that was started at the Center for Astrophysics by Alberto Pepi. Actually, when we first started it, Christine Borgman, whom maybe many of you know, started correcting everything in it. And we said, no, Christine, this is an experiment. But we've opened it up for commenting. And so this was a comment from someone saying, well, if you offer these DOIs, then you should allow it within the references so that people can actually cite their software appropriately. So I think one of the places that really does this well is Faculty of 1000, right? So they actually highlighted here software availability, but it's also down, if you can see it, it's down in the references area as well. So there's clearly some more work to be done here, but I think that's a great step in the right direction. And sort of vice versa, this is what it looks like on Zenodo when the software is deposited. It's gotten a little bit better now because now you have cross-linking with GitHub, and you have a README file that can appear on Zenodo, so the README file for the actual software. But this is what it looks like because Zenodo uses DataCite, like many other repositories, right? And in our library catalogs, now we're increasingly tying into DataCite. And this is what it looks like. It categorized as research data sets at first, or an article. So clearly, that's something that we also need to work on here. But maybe I'm not convinced that it needs to belong in a library catalog. There are a lot of projects out there right now that are trying to do indexes for software. There was a software discovery index report out of NIH. We have the Astronomer source code library that actually does very simple linking between papers and software. But this other project that's really interesting is called libraries.io. And libraries.io actually mashes up all this useful information into a discovery interface. It's very, very interesting to see how that tool is developing. And there's some other things, other discovery services on the side, like DIRT. The DIRT directory is a humanities discovery interface for software. And then there are software journals appearing. And they're getting some use. Still some work to be done, but and actually Elsevier just launched a software journal called Software X. It's open access, and we have an astronomy and computing journal for software as well. And there's different takes to how they what software they review and what they accept. And there's some other sort of related ones at the bottom there, but I'm sure I'm missing some as well. I just wanted to show you some examples, but it seems like this is an increasing, this is becoming increasingly of importance. So one of the things we did at the Center for Astrophysics Library is actually look at the metadata from GitHub and Zenodo and see how can we curate this better? How can we, as librarians, help in this process? and these were my graduate students that were part of another project, which maybe I can talk about a little bit more too, which was called Data Scientist Training for Librarians. So they learned how to do more sort of advanced curation, digital curation. And so we started looking at this and seeing the obvious things that the authors in GitHub are not very good at describing their software with the tags. Also with automation, it's also very difficult to describe when we automated. So we actually used a tool called Semantria. Oops. Well, we used a tool called Semantria, and it actually it captured a lot of computer science terms. And so this is really an area where we could work on. I turned off the play, by the way, but it's all right. It's all right. Another thing is that this was an obvious thing. You know, what languages we're using, what languages were being used, and one of the interesting things is you had even full-on packages called, for instance, Julia, which were actually being cited in Wikipedia. They were actually using a tool to cite their language. And so this was sort of the first take on where people are coming. It's really distributed around, it's a really bad mapping job on my part, actually, by the way, now I'm looking at it. But it's really you know, it's in places like Europe and North America, but I think we've been seeing it being used, this process being used more and more around the world. And the other thing we saw was that the licenses, the developers were really not very good at choosing their own license, and that's something actually GitHub has acknowledged itself, and it created this tool called choosing an OSS license. But even after this, people weren't really still using it, and so they've actually moved. And these are actually some just some graphs to show how that usage was really dropping, and they knew that trend was happening. But they also show the most popular licenses, MIT, Apache. But like they created a tool called Licensee, an API, to help with this process, to help with assigning licenses more easily. And Dan Katz, who's actually here at University of Chicago, and he actually he's very interested in research software as well. And there is no linking to funding agencies, and they're very interested in how they can see if they are going to fund research software, that they can see, you know, how it's being used, how previous similar research software has been used, so it can inform their decisions. But so we actually recently met at GitHub to talk about how we can improve this whole process, and it was very interesting to hear that we didn't use any library things like, you know, any of our standards like BibFrame or anything like that. We use JSON LD, which is JSON linked data or schema, but there was really no mention of that, and we actually started developing based on a project called CodeMeta, which was started really, I think, between Arfan and Caitlin, and I know I'm missing someone here, but they started sort of to imagine how can we describe research software, right? And so on the right, that's actually a JSON file, linked data, and then on the left is actually the context. So this is the schema, schema.org context, and so you can see over here they're very much interested in using ORCID, and there's still some work to be done though. Like they have the links to the license and the version and other things like that. So we're still somewhat working on this, and I think one of the other things that came up, and this is a very bad image, sorry, like I didn't have enough time to rework this because the workshop happened just like 2 days ago. And I think you can see me in the background taking the picture here, or Alberto Akamazzi from the ADS who's scratching his head. But we were trying to, it was an interesting conversation because we looked at how authors describe their software as opposed to how the curators describe it, and how they were in conflict, right? And so that big X in the middle is, there's a disconnect. And so I think we really started going into a direction that was what was interesting for librarianship, which it uses the terminology of GitHub, which is a pull request, right? So you send a pull request to an author and say, I noticed that you don't have this particular information. Can you update your metadata, to reflect some of this other additional metadata? Meanwhile, this has really happened recently as well. Coming from the astronomy community in Leiden, they had a big meetup, and they started asking the question, is software a primary product of research? And it really kind of blew up Twitter. I think there was a real long discussion about this, and even blog posts, I think by Titus Brown, and so he had to backtrack a little bit on explaining how he thought, how he saw software, but some other people saw it as an important part of the research project, of the research process. So it's interesting to see this discussion going back and forth, and I just think there are more and more people that believe that this is something that should be credited. It should be also discoverable and here's a group in the UK that basically blatantly says it on their site. But I think of again the role of libraries and how we can how can we help in this process, and I think absolutely the way that my library has been sort of in this process is that we've retooled. We've learned some of the new technologies that are out there and tried to understand the research workflows better, right? And so that comes out of a training program that I started at Harvard called Data Scientist Training for Librarians, and so it really allows us to go through the research lifecycle and understand these tools better. And I think GitHub is really a critical part of that research workflow, in my opinion. And so I have them much bigger than some of the other partners that we have on there. But those are some of the other people that we're working with. And I think we wouldn't have been at the table in those conversations unless we had actually retooled and we had upgraded our skills and been a part of that conversation. And actually one of the key goals of data scientist training for librarians is that you at least understand this research workflow better, so that when a scientist comes to the library, comes to the desk and has a question, that they don't immediately turn away and say, I don't think the library understands what my needs are. And so that really is to respond to what I see as a sort of more dynamic documents that are being produced in the community. And this is just to end on this example, the IPython notebooks are being used more and more heavily for teaching purposes within my community, and sort of dynamic documents and the whole response with the Zenodo and GitHub infrastructure was to respond to this, to give people a way to cite this in the digital library environment and get credit for their open notebooks and other research software products. So thank you. If you have any questions.
I'm Maureen Clark from the University of Illinois, and I had some questions about, so people are going to get credit for research, hopefully, and but my question has to do with copywriting of software, issues around plagiarism then. It seems like there's a whole can of worms that gets opened up by the new status of this. In my background, I am a computer programmer, among other things. And so, I think that was, when I was doing it, not really too much of a concept, but I'm kind of wondering about licensing and ownership and, closing things down where there might be a wish to open things up.
I think the trends that I've seen is that most of the time the developers of the software use open licenses, so it's been more common. But you're right that can be problematic. But for the most part, I'm just seeing that the community in general is very open with their software and do want it to be more discoverable and to be open to reuse. Again, I come from the astronomy domain now, so that's maybe a view that I'm reflecting from my domain. But that's what I've been seeing, is that there's more just energy around the process of making this available and creditable, that I think it might become more just common practice to do. And many of them actually, and I alluded to it before, that that they really leave out the license. So that's more of a problem, like they don't really license their code. So thankfully we have Github that's concerned about this as well. And they really do try to, I think everyone tries to encourage be more open, with your code as well. But yeah, I echo your concerns too.
Deborah Ruck from Medical College of Wisconsin. I'm really curious what type of integrated library system that you use and what you use for your discovery layer. And if it appears that you're putting records into the system, are you using a MARC record, a modified record, or something totally different for your software?
Totally different. Actually, that's an interesting thing, because we have this, we work with the Harvard Library System, but in general, we're more concerned about our the astronomy community, so we use the NASA astrophysics data systems. So all of our curation, all of our work goes into making that a better tool, which is indexed by Google. And I think for years, the ADS was sort of, I remember comments about the metadata not being perfect, and because they accepted journal metadata, and they still do. That's sort of the canonical version that they use. But they that's always been something I think that libraries are sort of attacked about the ADS. But I'm on the other side of it, saying it's discoverable. That actually, and I think curation is just an ongoing thing. Mm-hmm. You're always going to go back, and so I think it's been such a great tool for us to actually constantly cycle back and add more of this rich data linking. And astronomy has been one of those fields where I actually developed a tool at European Southern Observatory where we actually mined the literature because it was open and created these data links. So the astronomers, I think we do a bad part of giving ourselves attribution. Giving that the librarians get credit as well. And I actually talked to the ORCID people about that. Why can't librarians actually use ORCID for doing stuff like this too? But the astronomers themselves don't really know that there's all that work happening underneath. And so we do have a problem where the NASA astrophysics data systems is well loved. I challenge you to find any astronomer that says they hate it. Like they actually always love it. And but they'll click on these data links and say, that's great. The ADS provided these links, and there's a real, there's a community underneath that actually mines all that stuff and adds value, right? Mm-hmm. And so that's been working really well, and with the limited metadata that we still have. But I work with the publishers as well to get them to contribute the full text to the ADS so we can do this kind of work.
Mm-hmm. Thank you.
You mentioned that at least some places in literature, they're starting to use citations to code. Are there any journals that you're aware of that are actually requiring it, or are there standards emerging that would sort of lead to that in the journal literature as well as elsewhere?
You might find it hard for them to require it that's actually something that was discussed. And by the American Astronomical Society and IOP, the Institute of Physics, were in this workshop with us recently, and they had a hard time with that mandating. But I think they were really being considerate, because they didn't want to mandate something that still wasn't seamless to them. Like the citation, the whole process, the citation, the publication, other things of of code. And I showed you that, that horrible picture with an X in the middle of it, where we have all this disconnect between how authors are citing their code still and how sort of the curators and how the astrophysics data systems wants to do it, and sort of like 4 instances of how people were thinking about doing this. And so they were really concerned about actually just making it easy, finding a process that everyone could get on board with. And I think probably every other publisher will think the same way, that they want, well, I know Cameron's giving me, but I think they would want this process to be more meaningful, more seamless than, yeah.
This is actually kind of a half-formed question, I have to admit. And in some ways it ties a little together both Chris and Cameron's presentations. And you're talking about scientists at CERN really made me think about, I've been involved in a project with some of the HEP scientists working actually on data software preservation. They're very concerned about how to do that, and not just the citability, but the real, how do you keep software long-term? And so all the issues around the environment that it requires, and all those dependencies and such. But what I've learned in the process of working with them is it's a very interesting model they have, that not only, as Cameron commented, do they throw away the majority of their data before they even, in the milliseconds after it comes off of, the detectors, and that they're dealing always with this process. But the way in which they are a community and a club in many ways, and the way in which I was really interested to hear them refuse to talk about who had discovered the Higgs boson, that it was in fact a collaborative process to decide when and at what point they could make that announcement, that it was, there are 2 different completely separate groups that work on similar things, the ALICE and the CMS, and that it came jointly out of both of those groups that usually work much more independently because they detect the same type of things, but they have detectors that work in very different ways. And so I wonder what we might learn from, they really almost offer a new or different model of ways in which they collaborate. And I think the astrophysicists also have a very collaborative process around, and they have to in some ways because of the big expensive instruments they have. But it made me wonder what we could learn from them and think about how might that become metaphors or actually realities of structures that could be used in other sciences.
So, that one? And the particle physics community is fascinating, and I can never really figure out whether we can really draw lessons from them or whether it's entirely different. And because the obvious difference being there's so much money at stake that there are certain things that have to happen. There has to be governance, there has to be trust, there has to be management of exchange rates, for heaven's sake. So there has to be this really serious focus on infrastructure. There has to be this really serious focus on managing the data, and it can't be done. The science cannot be done by less than thousands of people. So I'm still really trying to figure out, as are many other people, how to disentangle the things that are specific to that community and the things that aren't. And I think you put your finger on at least one of the 2 major comparators that I think are useful. One is the astronomy community, very similar in terms of coming from a similar disciplinary background, also very big kit, but more dispersed, and maybe not quite as expensive, though that's changing with the SKA, I guess, and LSST. So that's going to be an interesting thing to observe. But there's another large facilities community in the material sciences and in chemistry. And again, you'd think, and that's actually where I came from before I moved to PLOS. So I've seen these communities close up, and so they come from a different disciplinary background in terms of being in chemistry. They also have very large facilities. They have governance mechanisms that are not dissimilar to the way that CERN works, but tend to be on a slightly smaller scale. But there's much less of the sharing and coordination that happens. And I'm interested in trying to tease apart whether that's because chemistry is traditionally a much more individualistic discipline, or whether it's because there's much different types of science going on in those facilities compared to a CERN, or if you're going to go to ESO, you're doing astronomy. If you're going to go to where I used to work, the ISIS neutron source, you could be doing anything from quantum physics through to biology. So I don't know the answer, but I think they're interesting things to figure out.
Well, I just think one other thing, though, is that there are differences even within our communities, right? Like, I think the general thing to say is that, astronomy data is all open, but it isn't. It isn't. Like, some groups actually control access to it. And what I think is, and it's not entirely unique, but these big projects. So I actually was just thinking about the time of they were developing these telescopes with the great observatories, right? And they had to come together. So much money, so much infrastructure is being built that they had to come together and agree on sort of commonalities, common norms for the community. And so those kind of events actually, I think, inspire the rest of the community to sort of do the similar things in the end. So that money coalescing around big projects has an impact in in other areas within the community.
I think, the other thing that strikes me when you say that is so the other place where this obviously happened was in the Human Genome Project. So again, you have large amounts of money, large coordinated effort, but maybe we don't. So it struck me is that maybe we don't also recognise the critical importance of individuals in pushing those decisions. So the story we tell about the Human Genome Project is that the Wellcome Trust and the NIH dictated. But they only did that really because Francis Collins and John Silston marshalled a community to say, you should dictate to us. And I don't know the history of astronomy or particle physics well enough to know whether there were sort of critical people.
They write books. And that's where everyone gets named in the book, yeah.
But I guess whether it was, are there particular people that really at the beginning of CERN, for instance, that took decisions that pushed in that direction of making things public, of being open? I mean, you imagine Tim Berners-Lee working anywhere else except CERN, the world would be a very different place today.
Yeah.
But it's so embedded in the culture that was the obvious thing, was to throw it out in the public web, into the public domain. Yeah, that's got a really deeply embedded culture.
Those people also break out or branch out that has impacts in sort of interdisciplinary ways, or yeah.
Well, it seems to me they also very much created structures within their groups that kind of address some of the concerns and problems. I mean, everyone talks about the open data that the astronomers make, but they don't release it the first year. And they have, there's a lot of structure that they actually created. And again, someone was behind thinking up what would create the motivations and the checks and balances. And without that, it probably might not have happened and gone down that path.
I wonder if we can learn different things if we look at a different kind of community, rather than looking at a discipline-specific one. If we look at geospatial users that cross different areas, very different world. If we look at chaos theory that automatically crosses different worlds, we're probably going to see very different structures and infrastructures. And that may be what, in the long run, has a much better long-term infrastructure than these individual disciplines.
Yes, absolutely. And tool use as a defining, communities of practice are defined by the tools they use in many cases. It's interesting, you're actually mirroring a conversation we had internally at PLOS a little while back when we were asking the question, if we're going to roll out some new offerings, which communities should we focus on? And so, the answers came back, we should talk to the geneticists and the neuroscientists. And I was saying, we should talk to those scientists who edit Wikipedia, or those scientists interested in aspects of opening up peer review, or those, that was because you have, greater leverage there. I think for me, so the way I think about the sort of, if you like, the social engineering that I'm interested in trying to achieve here is that what the literature on collective action tells us is that essentially groups come together to solve problems that they share and have collectively. And some of those communities are easier to see than others, but they generally, the way this happens, the way cultural change and collective action happens, is a group comes together to do what they think is the right thing, regardless of whether it's in their personal interest. And then that group starts to expand and get more traction. And then at some point you run into this space. You can talk about this in terms of technology adoption and Christensen and the innovators developed dilemma, or various other sort of technology transfer kind of ways of thinking about it. But you reach a point where people are not, the group's now big enough that people are not just going to do it because it's the right thing. There needs to be some sort of incentives. But something else happens, because there's generally another group over here, often motivated by similar things, but not necessarily exactly the same things, not necessarily completely aligned. And one thing that does often happen, and one might suggest that this is a characteristic of some aspects of the open access debate, is that sometimes when those groups start to meet each other, they actually become opposed and you get political stasis. And this is common in political change in lots of settings. So my theory is that there are two things we can do. We can support a group over here and a group over there and happen to give them interoperable infrastructure that sort of helps to align them. That might be a role that societies or libraries might want to play. But also, because these communities will overlap, because they don't have to be defined by their discipline, by their technology, or as we were, not so long ago, we were pretty much restricted by geography, much less so today. So we have lots of options to think about how these groups are overlapping and how we can turn. Nick Souza at the Queensland University of Technology has this nice phrase, I'm not quite sure how to make it work yet, but the object is to turn clubs into networks, or wire clubs into networks. And so these clubs or communities that cross over each other, the Python community in the biological Python community and the astronomical Python community have something in common. And can we use that to drive cohesion? I don't know how, but it seems like it should work.
I just wanted to add one more thing to that I think there's some interesting work being done by Chris Lintodd and the Zooniverse people, the citizen science people, to actually even open up this network further and to really reduce the barriers and allow people. I think it was impressive that they actually had a project called Quench, which used actually Authoria to write a paper with all the citizen scientists, right? And so I think that's sort of an interesting, another angle on this, of opening it besides just the clubs, the scientific clubs, to the actual community outside.
Yeah, these communities don't have to stop at 53rd and Ellis.
Related to, I think, this last question, what would be the role of legislation in bringing it club goods to public goods? I mean, it creates all sorts of resistance from those members of the club, but is that really the only way to get, or should it be the more organic collective action that you're describing, Cameron? So
you want, in an ideal world, you manage to apply both. In an ideal world, what happens? And again, refer you to the work of Ostrom and her research group, and who really worked on this for many years. There are a couple of different things that happen. Either groups start to come together, and somehow through luck, in many cases, they are there's enough cohesion that they retain alignment and things actually change. What generally happens in those circumstances is actually that you end up with these flips, and you end up with sorry, I'm going to drift into a physical sciences analogy. I apologise to the people in the room, but there's a thing called a spin glass, which happens when you have lots of little magnetic fields in a material. And what tends to happen is that as you quench the fields, they end up flipping over and the whole thing becomes non-magnetic. But the way to fix that is at the right point in time and at the right temperature to impose an external field on the system. So legislation is an external field on the system. The question is, when is the right time to apply it? Because the ideal time is when the community very strongly believes that this is the right thing to do, and you're just about going to do it, but no. And seatbelts are probably a particularly good example of that. I choose an example not from scholarly communications just to be on the safe side. But I think you can certainly make a case that the mandates in the UK have come too early. I think that would certainly be an argument you could advance. It would be worth exploring. So I think what's new is that we can think about, if we step back, we can think about helping these groups interact and coordinate, or if you want to stretch my physical analogy to its breaking point, we can think about different kinds of fields that can be applied by offering interoperable technology, platforms, infrastructures that make things easy. And so what I'm really interested in, and why I keep coming back to this club goods, public goods, how does that return goods back into the club space? So in a pure economic analysis, the question becomes one of what do we build to make the process of the club deciding to invest in making things more public cheaper for the club, infrastructures, technologies, and what do we build that maximises the benefits so that something comes back to that club. So I think what's new about the web is that we can consider building technological systems and platforms that help us get from scattering of groups of people thinking that the world should change, but not necessarily knowing of each other or working together. And again, the open science community is a million different bubbles not talking to each other. How do we get from there through this difficult political place where people start bumping against each other and, our Centre of Open Science got that grant and I can't do that work and they're just sucking up all the money, or, those kinds of issues. And I'm picking on them because they're nice people. Through to the point where it becomes obvious that the best way to finally get everything into alignment is to just bring the hammer down and say, yes, this is the way that things are done now. But it doesn't have to be mandates again. Classic example, the open access mandate at the University of Liège is not a mandate. There is no requirement on any member of staff to put anything in the institutional repository at the University of Liège. It just so happens that the way your CV is generated for your annual appraisal is by taking things out of the repository. But your choice, put it in, don't put it in, up to you.
All right, thank you very much. I think we're at time now, so let's give a round of applause to all of our morning speakers.